Homework 36 starts off with finding the angle between the two vectors. So we're going to have a formula for this, and it's going to tell us that the cosine of theta is equal to the dot product of A and B. We just did the dot product on the other page, over the magnitude of A times the magnitude of B. And again, we've done that on the previous page. So that's our formula that we're going to use. If you really want to know how they came up with that, you can read the Alex explanation that explains how they came up with the formula, but that's what we're going to do. So we're going to say that the cosine of theta is equal to the dot product. So the dot product meant we took the negative 6 times the 9 plus the 1 times the 4 over the magnitude of each of those. So for the magnitude, we did the square root of a squared plus b squared. So I would have negative 6 squared plus 1 squared times the square root of 9 squared plus 4 squared. So, simplifying that mess. This would be negative 54 plus 4. So I would have negative 50 on the top. On the bottom, this is going to give me 36 plus 1, which is 37. This is going to give me 81 plus 16, which is 97. So I have to multiply square root of 37 times the square root of 97. Don't know that in my head, so I got to find my calculator, which I put over here. So if I multiply 37 times 97, I get 3,589. Now the cosine of theta is equal to this. In order to find our angle, which we're doing to the nearest degree, so make sure your calculator is in degree mode, we are going to do the inverse cosine of negative 50 over the square root of 3,589. I'm going to use the parentheses again since I have a fraction. I always like to put the parentheses around there. So shift cosine, inverse cosine of, in parentheses, negative 50 divided by, or fraction, square root of 3,589. Close my parentheses, hit equals. I get 146.575. I'm rounding to the nearest degree, so I would have to round that off to 147 degrees. So the angle between this vector and this vector would be 147 degrees. If I kind of just sketch that out, negative 6, 1 would be the vector going like this. 9, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4 would be the vector going like that. This angle in here is 147 degrees. That looks like it makes sense. So number 2, it wants us to find the angle between the negative 9, negative 7, and negative 4, positive 3 vector. So again, we're saying that the cosine of theta is equal to the dot product of my two vectors. So negative 9 times negative 4 plus negative 7 times positive 3 over the magnitude of each of my vectors. So we're going to have negative 9 squared plus negative 7 squared, and then negative 4 squared plus 3 squared. So simplifying that mess, negative 9 times negative 4 would be 36. Negative 7 times 3 is minus 21. So 36 minus 21 is going to give me 15 on the top of my fraction. On the bottom, negative 9 squared would be 81. Negative 7 squared would be 49. If I add those together, I get 130. Over here, negative 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. So I have the square root of 130 times the square root of 25. I'm just going to multiply those two things together and not worry about simplifying. 130 times 25 gives me 3,250. So again, if I'm going to figure out what my angle is, I'm going to do the inverse cosine of my fraction there. 15 over the square root of 3,250. Making sure I'm in degree mode because I'm going to the nearest degree. So shift cosine to do inverse cosine, parentheses 15 divided by the square root of 3,250. Close my parentheses. I get 74.744. I'm rounding to the nearest degree, so that would round off to 75 degrees. Again, if I think about that, my one vector is going -9 and -7. So it's going down this way. My other vector is at -4. 1, 2, 3, 4, positive 3. 1, 2, 3. So it's going up this way. The angle between those two things ends up being 75 degrees. Looks like it makes sense. Number 3, same kind of thing. The cosine of theta is equal to the dot product of my vectors. So 8 times -8 plus 5 times 7 over the magnitude of my vectors multiplied by each other. So 8 squared plus 5 squared and -8 squared plus 7 squared. So 8 times -8 would be -64. 5 times 7, going to give me 35. So -64 plus 35 gives me -29 on the top of my fraction. On the bottom, 8 squared is 64, 5 squared is 25, so that is going to give me 89, square root of 89. 8 squared is 64, 7 squared is 49, 13, 7 plus 4, 7, 8, 9, 10, 11, 113. If I added those right, I'm just going to quickly double check. 64 plus 49. 113, yep. So now I'm going to multiply my square roots together. 89 times 113 gives me 10,057. So again, if I'm going to calculate my angle, I'm going to do the inverse cosine of -29 over the square root of 10,057. So shift cosine, parentheses, -29 divided by square root of 10,057. Close my parentheses. I get 106.808. I'm rounding that off to the nearest degree, so 107 degrees would be my answer. And again, if you wanted to sketch it out, you could look to see that. Hopefully that makes sense. So, again here, when it wants you to compute the angle between your two vectors, you're saying that the cosine of theta is equal to the dot product of your two vectors, and then on the bottom, the magnitude of each of your vectors times each other. 4, 5, and 6 wants us to find the component of a vector along another vector. Says the vectors u and v are shown below in the figure. Find u sub v. The component of u along v. Do not round any intermediate computations and round your answer to the nearest hundredth. So, in order to find the component of my vector, I'm taking the magnitude of u, since I'm doing u sub v, so it's always the magnitude of whichever one the first one is, u in this case, times the cosine of my angle, cosine of theta. So, we look for the one labeled vector u, which is this one. It already has our magnitude on there. the magnitude of u is just going to be that 29. We want to take that times the cosine of our angle. Now we want the angle between here and here. So we know this little section is 35. We know right here is going to be 90. We still need to find that little section in there. So since that's a right angle, I can take 90 minus my 67 in order to find that angle there. 90 minus 67 is 23. So we know that little angle in there is 23. So I'm going to have 35 plus 90 plus 23 to get all my little parts of my angle. 35 plus 90 plus 23 would mean 148. So I'm going to have 148 degrees up there. And so again, I'm in degree mode. Make sure your calculator's in degree mode. You're just going to type in 29 cosine of 148. I get negative 24.59339. I'm going to round my answer to the nearest hundredth, so negative 24.59 is going to be my answer. Just a little note, if this angle in here is an obtuse angle, like this is, it's more than 90, I will always get a negative answer. If it's an acute angle, one that's less than 90, then I will get a positive answer. So since this was obtuse, I should get a negative answer. I did. Just a little quick way to kind of double check yourself. If it's obtuse, I get negative. If it's acute, I get a positive. So number 5. Again, we want to find u sub v. We're going to do the magnitude of u times the cosine of our angle. So if I'm looking at this one, here's my vector u. The magnitude of that is going to be 24. I want to take that times the cosine of my angle. So I need to figure out what my angle is. So both of these I need to figure out the inside. So here I'm going to do 90 minus 68. Over here I'll do 90 minus 42. 90 minus 68 is going to be 22 for this little piece in here. And 90 minus 42 going to be 48 for that piece in there. So 22 plus 48 gives me 70 degrees. So all I'm going to do is calculate 24 times the cosine of 70. So 24 cosine of 70 gives me 8.2084. Rounding to the nearest hundredth, 8.21 would be the answer to the question. Find the component of u along v. Again, this was an acute angle less than 90, so I ended up with a positive answer, which is what I should get. Number 6, the vectors u and v are shown below. Find u sub v again. So I'm going to do the magnitude of u times the cosine of my angle. So in this case, here is my vector u. The magnitude of that is labeled as 15. On my angle, this one is 44. This one right here would be 90. I need that little part in there. So 90 minus 69 gives me 21. So that little part in there is 21 degrees. So to find all the way from here to here, I'm going to take my 44 plus my 90 plus my 21. And I get 155. So I'm going to do 15 times the cosine of 155 degrees. So 15 cosine of 155 gives me negative 13.5946. I'm rounding to the nearest hundredth, so negative 13.59 would be my answer. And again, since my angle was an obtuse angle, I should end up with a negative answer, and I did. So I'm finding the component of my vector. I have the magnitude of my main vector times the cosine of the angle between the two vectors. 7, 8, and 9 are plotting points in the polar coordinates. When you do polar coordinates, you have your direction, and then you have an angle. So, if I'm going to plot where negative 4 and 11 pi over 6 is, I'm first going to go to negative 4. So 1, 2, 3, 4. Right there's my negative 4. You'll see there's a little circle there. I'm going to do 11 pi over 6. I'm going to go clockwise around because it is positive. And so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 6 pi over 6 would be 1 pi halfway around my circle. 7, 8, 9, 10, 11. I would end up right there. That's where I'm going to put my dot. So I went to negative 4, and then I went around 11 pi over 6, and that's where I put my mark. So on number 8, we are doing the polar coordinate that is at negative 5 and negative 2 pi over 3. So negative 5, 1, 2, 3, 4, 5 would be this ring right here, negative 5. Negative 2 pi over 3, since it's easier to count with pi over 6 because that's each of my thirds, I would say negative 2 pi over 3 is the same thing as negative 4 pi over 6. Now since this is negative, I'm actually going to go back 4 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 would put me right there because I'm going to go backwards, negative 2 pi over 3. I could have made that a positive angle by adding 2 pi to it, but probably just as easy to do the negative and just go backwards. Your negative 2 pi over 3. And number 9, if I want to plot that one, I'm going to start at 2. So here's my ring where 2 is. I'm going to do a negative 11 pi over 6, so I'm going to go backwards. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. I'm halfway around my circle. 7 pi over 6, 8 pi over 6, and 9 pi over 6 would be 3/4 of the way around. 10 pi over 6, 11 pi over 6. So right there, I started here, I went backwards, negative 11 pi over 6, and I ended up right there for my mark. You're just going to mark where that ending point is, and so I would just mark right here where I have my X. So polar coordinates give you a direction and then an angle that you go around. 10, 11, 12 wants you to write a complex number like negative 1 plus 2i. Complex numbers have imaginary numbers. And they want you to change it into trigonometric form or what's known as polar form. So remember on that previous one when we had that polar form, we had the direction and then we had the angle. So it tells us here that in order to do that, z is going to equal r times the cosine of theta plus I sine of theta. Now r is my radius, and so if I'm thinking about this again with my right angle, negative 1 would be back 1, 2i, we're just going to ignore the I part of it and make it a 2, and so my radius is still again using my Pythagorean theorem is the same thing as when I'm finding the magnitude. I'm just finding the length of this direction right here. So I'm going to do a squared plus b squared and take the square root of that. So in this case, I'm going to have the square root of negative 1 squared plus 2 squared. So 1 plus 4 gives me the square root of 5. Now again on this one, we want to have our values rounded off to 2 decimal places. which tells me I don't want to leave it in radical form. I want to change it to a decimal. So I'm going to calculate there what the square root of 5 is. Square root of 5 is 2.236, so rounding off to 2 decimal places, 2.24. So z is going to equal 2.24, and now I got to find the other part of that. Now, if I think about this, the angle is what I'm looking for. So again, I have the opposite and the adjacent, so I'm going to do the inverse tangent of the opposite over the adjacent. Now this is going to be in radians, and so you need to switch your calculator from degree mode to radian mode. So mode 2, so that I have a little r on the top, tells me I'm in radian mode. I'm going to do the inverse tangent of the opposite over the adjacent, so 2 over negative 1, so the inverse tangent of negative 2. So shift tangent of negative 2 gives me negative 1.1071. Now, they're going to want these angles in the positive direction instead of the negative direction. And so in this case, this is the negative 1.1. I actually want to find the angle here. And so this way from here to here is pi, right? It's half a circle. So pi, 3.14159, or use the button on your calculator. So I'm going to take pi minus my 1.1071. Again, they don't want you to round off too soon. Don't round your intermediate computation. And so I'm trying to find the angle from here to here. On my calculator, I have a pi button. It's in yellow. So I'm going to hit shift, pi, and then I'm going to subtract my 1.1071. And so now I get 2.0344. I'm going to round that off to the nearest hundredth, so 2.03 is what I'm going to use there for my angle. So I'm going to have cosine of 2.03 plus I sine of 2.03. And that's how my angle is going to look as a polar form or trigonometric form instead of in complex number form or imaginary number form. So my radius, finding the magnitude of this line here, just like I did before, the square root of a squared plus b squared. Then I'm going to find this angle. If this angle is negative, I've got to convert it to the positive direction. So in this case, to figure that out, I would have had to take pi minus my angle, and then I can find what this measurement is here. So number 11, we want to write the complex number z equals 2 plus 6i in trigonometric form. So thinking of that, this being 2 here, this being the 6 here, and my angle is going to be there in quadrant 1. So first of all, calculating r, square root of 2 squared plus 6 squared would give me 4 plus 36, so square root of 40. I'm going to use my calculator. Square root of 40 gives me 6.3245, rounding to 2 decimal places, 6.32. So z is going to equal 6.32, and then I'm going to do the rest of my problem there. For the rest of my problem, I'm going to use the inverse tangent. So inverse tangent of the opposite over the adjacent, so 6 over 2. So inverse tangent of 3. My calculator's in radian mode. Shift tangent of 3 gives me 1.249. So rounding that off, I would use 1.25. That is a positive, and notice I'm in quadrant 1, so that is my angle that I want to do. So I'm going to have the cosine of 1.25 plus I sine of 1.25, and so z is equal to 6.32 cosine of 1.25 plus I sine of 1.25. Number 12, same kind of thing. Thinking about this in terms of my right angle, I'm at 6, -5, so I'm going to be down here. So, finding my r. R is going to be the square root of 6 squared plus -5 squared. 36 plus 25 gives me the square root of 61. So I'm going to calculate the square root of 61 with my calculator. I get 7.8102, rounding to 2 decimal places, 7.81. So z is going to equal 7.81 times, and then I'm going to do the rest of my problem here. So I'm going to do the inverse tangent, and my opposite would be -5 over my adjacent 6. I should have probably wrote that up there. It would have looked better up there. So, opposite over adjacent, -5/6. Because it's a fraction, I'm going to use parentheses around that. Inverse tangent of parentheses, -5/6 gives me -0.6947. Again, that's a negative measurement, so I'm going backwards from here to here. I really want the angle going around from here to here. So in this case, 2 pi would be all the way around. I'm going to take 2 pi minus my 0.6947. So on my calculator, I'm going to do 2, shift, and get the pi button. You could use 3.14159 if you need to round off pi if you don't have a pi button. But 2 pi minus my 0.6947 gives me 5.5884. So 5.59 is what my angle would be in the positive direction. And so I'm going to have the cosine of 5.59 plus I sine of 5.59. Smoosh that all in there. And that's going to be my answer in polar form. So always look if you do get a negative angle where you're at, because you want your angle in the positive direction. If it's up here in quadrant 2, you're going to take pi minus the angle. If you're in quadrant 3, you would take pi plus your angle. If you're in quadrant 4, 2 pi minus your angle. (13, 14, and 15). I'm probably going to say this wrong, but you're using de Moivre's theorem. I'm sure that's got to be a French guy, so if I spoke French, I'd know how to pronounce that. To find something to an exponent. I probably don't want to have to take 2 plus 2 square root of 3i times itself 6 times. That would not be very much fun. So this guy came up with this formula. I'm going to grab my paper here so I get it written down correctly. It says that if I have something to the nth power, what I'm going to do is take r to the n times the cosine of n times theta plus I times the sine of n times theta. Excuse me. The r again is your radius. So again, we're thinking about having our right angle. And if I was at 2 and 2 square root of 3, ignoring the I, I'm finding this value here by using that formula we use for magnitude, or just finding the radius using our Pythagorean theorem. So r is going to be the square root of a squared plus b squared, just like we've done a million times up to this point. Or at least it seems like that. So r is going to be the square root of 2 squared plus 2 square root of 3 squared. So 2 squared is 4, 2 square root of 3. If I'm squaring that, I'm taking 2 square root of 3 times 2 square root of 3, which is 4 square root of 9. That would make that 4 times 3, so that would give me 12. I end up with the square root of 16, which is 4. So I'm going to have a 4 to the 6th power, because this was to the 6th power. So I'm going to have 4 to the 6th. Now again, I have to find my angle. And just like before when I found my angle, I am going to use the tangent is opposite over adjacent. So I'm going to use the inverse tangent of 2 square root of 3 over 2. So that would mean I have the inverse tangent of square root of 3. Now, this is going to be in degree mode, so really if you wanted to use, or no, it's actually in radians they're going to use it. We are going to just use that table that we had before. I'm not going to flip over to the table right away because then erase my whole board. But this table here that we had, all of our angles between 0 and 2 pi, or with our sine, cosine, tangent, and all of those things. We're just going to use the tangent column in this case. But I'm going to look for, we are in quadrant 1, and I want to find the inverse tangent of square root of 3 and what angle that is. So in quadrant 1, if I look under my tangent column for square root of 3, I see that it's equal to pi over 3. Suppose I could have used the degrees also. 60 degrees wouldn't make any difference which one you use. So I am going to have the cosine of 6 times pi over 3 plus I sine of 6 times pi over 3. Coming down here, I got to do some calculating. So 4 to the 6th power, 4 caret 6 is 4,096. Cosine of, here if I simplify, 3 goes into 6 2 times, so 2 pi, plus I sine. Same thing, 3 goes into 6 2 times, 2 pi. So again, I'm going to use this table, and I'm going to look up the cosine of 2 pi and the sine of 2 pi. So I'm going to have 4,096, the cosine of 2 pi. 2 pi, looking under the cosine, is 1, plus I times the sine of 2 pi. The sine of 2 pi is 0. Well, this is going to make this 0. So I'm going to have 1 times 4,096. So my answer is just 4,096. So if I took 2 plus 2 square root of 3i times itself 6 times, I would end up with 4,096. So again, just to make sure you knew what table I was using now that I can clear my writing, I'm using this one here where we looked up the tangent of square root of 3, gave us pi over 3. You could have used the 60 degrees also, but so I could convert it. Then I went down to the 2 pi, which is, I'd have to scroll down to get to, which I could do. 2 pi, and I looked up the cosine of 2 pi, which was 1, and the cosine, or the sine of 2 pi, which was 0. And so I used my table a couple different times in order to solve my problem. So make sure you have that table handy. We've used it a lot. You should have it somewhere. If I go back to number 14 then. So number 14, we're using that theorem to find -1 plus I to the 5th power. So I'm thinking about having -1 and then a +1 because that would be a 1i, right? This would be -1 plus 1i to the 5th power. So I'm over here in quadrant 2. First of all, I'm going to calculate r. So I am going to do a squared plus b squared. So -1 squared plus a +1 squared would be 1 plus 1. square root of 2. So r is square root of 2. I'm going to have the square root of 2. I'm going to raise that to the 5th power. I'll get on with the rest of it here in a minute. So then I am going to figure out my angle. My inverse tangent is going to be the opposite over the adjacent, so 1 over negative 1. So I'm doing the inverse tangent of negative 1. And again, I'm just going to look this up on my chart here. I'm looking for in quadrant 2. So for quadrant 2, you'd be between the 120 and the 180. You're looking for the inverse tangent that's equal to negative 1. So looking there, I have 3 pi over 4. So I'm going to have cosine of 5 times 3 pi over 4 plus I sine of 5 times 3 pi over 4. So first of all, if I do the square root of 2 to the 5th power, 2 to the 5th power is 32. So I'm going to have square root of 32. I could simplify that, but I'm going to wait till later to see if I need to, depending on what my multiplying is. So over here, I'm going to have cosine of, that doesn't cancel, so I'm going to get 15 pi over 4 plus I sine of 15 pi over 4. Now 15 pi over 4 is more than 2 pi, so I want to think about when I have my thing that I'm going around, and how much farther do I have to go around? So I'm going to take my 15 pi over 4 and subtract 2 pi from it, because I'm trying to find the equivalent angle that's between 0 and 2 pi. So this would be 8 pi over 4. 15 pi over 4 minus 8 pi over 4 would be 7 pi over 4. So I'd be way around here at 7 pi over 4. So I'm going to do the square root of 32 times the cosine of 7 pi over 4 plus I sine of 7 pi over 4, using my equivalent angle that 15 pi over 4 is the same angle as 7 pi over 4. Then I'm going to look up in my table. So 7 pi over 4. The cosine is square root of 2 over 2. So I'm going to have the square root of 32 times positive square root of 2 over 2 plus I times negative square root of 2 over 2, which is the sine of my 7 pi over 4. So when I multiply this out, I'm running into the next problem, but that's okay. The square root of 32 times the square root of 2 would give me square root of 64 over 2. The square root of 64 would be 8 over 2. 8 over 2 is 4. Same thing here. I'm going to have I, and then I'm going to have negative square root of 64 over 2, which would be negative 8 over 2, which would be negative 4. So I'm going to have 4. Negative 4 times I would be minus 4I, and that's as far as I can simplify that. So if I would take negative 1 plus I times itself 5 times, I would end up with 4 minus 4I. If I hadn't taken so much space up here, I probably would have fit that all in that section. So hopefully you wrote a little better than I did instead of scribbling everywhere, so you could get it all to fit. Last one here. I'm going to clear the board so I've got a little more room, but it won't let me go up any higher. So I'm going to do 5 minus 5I to the 3rd power. I could take 5 minus 5I times 5 minus 5I times 5 minus 5I, but I can use my theorem here and hopefully make it a little simpler. So again, 5 would be here, minus 5 would be down there. I'm going to be in quadrant 4. So my radius is going to be 5 squared plus negative 5 squared. 25 plus 25 gives me the square root of 50. And again, I would simplify that, but I think I'm just going to wait and simplify it later. I'm going to have the square root of 50 raised to the third power. Then I'm going to have the cosine of, figuring out my angle, inverse tangent, opposite over adjacent, so negative 5 over 5 would be the inverse tangent of negative 1. I want to be in quadrant 4. So I'm going to look on my table, down in quadrant 4, between the 300 and the 360, inverse tangent equaling negative 1 would be 7 pi over 4. So I'm going to have 3 times 7 pi over 4 plus I sine of 3 times 7 pi over 4. So, if I take 50 to the third power, 50 to the third power, I'm going to have the square root of 125,000. Maybe I should simplify that, but I'll wait and see if I need to. Here, I'm going to do my cosine. Again, I can't cancel, so I'm going to get 21 pi over 4 plus I sine of 21 pi over 4. Again, that's bigger than 2 pi, so I'm going to figure out what my equivalent angle is. So if I went around once, I'd take off 2 pi. 21 pi over 4 minus 8 pi over 4, which is the same thing as 2 pi. 21 minus 8 gives me 13 pi over 4. Again, that's bigger than 2 pi because it's more than 8. So I went around once, I'm going to go around again. So I'm going to take off another 8 pi over 4, which is the same thing as 2 pi. 13 minus 8 gives me 5. 5 pi over 4 is where I'm going to be at. So 1 pi over 4, 2, 3, 4, 5. I'm going to be down here. Not that that matters. So, just because I have room to scribble up here, I'm going to rewrite this. I'm going to have the square root of 125,000 cosine, and we change this. That is equivalent to 5 pi over 4. So 5 pi over 4 plus I sine of 5 pi over 4. So square root of 125,000 cosine. Whoops, I don't even going to write cosine. I got to figure out what my cosine of 5 pi over 4 is. So I'm going to look it up in my table. 5 pi over 4. The cosine is negative square root of 2 over 2. Plus I times the sine, which happens to be the same thing. Negative square root of 2 over 2. So, checking this out, I am going to multiply. So I'm going to have negative the square root of 125,000 times 2, which is 250,000 over 2. Let's see if that happens to come out nice. So the square root of 250,000, 1, 2, 3. Ah, it does. It comes out to 500. So I am going to have negative 500 over 2, which is negative 250. Because this was the same thing, I'm going to get the same thing over there. So I'm going to get negative 250 for my first term, plus I times negative 250. So I'm going to have minus 250I. And so I get negative 250 minus 250I. If I would take 5 minus 5I times 5 minus 5I times 5 minus 5I. So again, I scribbled everywhere, all over the place. Hopefully you have some room down on the bottom of your page to write. But that's what I'm going to end up there with my answer. I could have probably started out this and simplified this. This was 25 times 2, and I would have had 5 square root of 2 and worked it like that. But since I'm using my calculator, I just left it alone. And I was lucky that came out to be a number that was a perfect square so that I could simplify it. But if you need to, or if it's not working out okay, you might try simplifying that before you cube it or do whatever you're going to do to it. Otherwise, at the end, you're probably going to have to simplify it And it might not come out as nice as it did on this one where it was a perfect square. So, negative 250 minus 250i is what we ended up with. So again, our theorem said that if we have r to the nth, or our z to the nth power, we are going to take r to the nth power times the cosine of n times our angle plus I times sine of n times our angle. And again, it's probably just as easy to use your sheet with your table of values in order to figure those things out.